Recording in progress.
Hello. Today I'm going to go through R syntax by following the R syntax comparison cheat sheet. So let's begin. And if you're familiar with R in any degree and you have your ways set, kind of which syntax you use, I still recommend you go through the entire video. You'll start to see some redundancies or maybe ways that you can clean up your code by choosing a different pathway for syntax. So why are there comparisons to be made? Well, R has numerous packages and tools to use to your advantage. And some of them overlap and combine for effective and powerful methods in data analysis, which is why R is such an attractive software program. That and because it's free. So with the numerous packages, there's a certain level of overlap between them, and that's what we're going to go through today. So we're going to go through the $ syntax, formula syntax, and tidyverse syntax. Depending on your preferred method of syntax, it'll be helpful to know the differences between each of these methods of syntax for when you are piecing together your code to visualize your data. So what's the general breakdown of these three methods? Well, $ syntax, the way it's set up, when you type it is as such. You have the goal or, what you're trying to create as a plot or get forward data, such as the mean, median, etc. Then you choose your data with a $ to depict what the data is, or if you have multiple sets of data, you can do both. The formula syntax, you start with the goal again, so mean, which we'll go over, and then you do your y by your x given z. We might not use all three of these at the same time, but that's kind of the general gist of this formula syntax. And then you tell it what data you're pulling from and how you wish to group it. Lastly, tidyverse syntax. You have your data, and then we're going to use pipes to discuss your goal. And your goal being the mean of what? So that would be maybe the specific subvariable within the data sheet. So moving into it, we're going to do some comparison examples with summary statistics to start. We're going to start with one continuous variable with the $. So if we're going to do, if you're joining me in typing this alongside, we're going to largely be using the mtcars dataset, which is a preloaded dataset that anybody can use in RStudio. So $, mean, depicting your data, mtcars, $mpg. So we want to know the mean of miles per gallon from the data set mtcars. Control Enter, and you can see down here in the console, it's 20.09, etc. As for the formula syntax, if you haven't installed this package already, you will need it in order to run the formula syntax. There's a whole nother cheat sheet on Mosaic. Each of these packages have their own levels of power for visualizing data. So they are equally effective. We're just discussing how they overlap today. So install packages Mosaic. Note, this will take a while. So it's going to load in the console it might take you a couple minutes. Just be prepared for that. So if you're loading it, pause the video, come back. Then we're going to do library Mosaic, and then we're going to run mean tilde. You have to always use the tilde. So by MPG, the data is mtcars. Again, in the console, we get our result, 20.09, etc. It's the same as before. It's an overlap. Lastly, if you're using the tidyverse, you'll need to install the package dplyr. I've already done so above for prior tutorials, but if you haven't, do install packages dplyr and then load it into your library. And here we have mtcars, and you use the pipe to tell it that we want to summarize the mean of miles per gallon. Don't panic if it doesn't show up in the console because it'll show up at the bottom of that section in R Markdown. So 20.09, etc. It's the same as the other two. And that's just the first example we're going through today with one continuous variable. Now with one categorical variable, we're going to do similar comparisons. So with the $ method, we're going to do table empty cars by cylinder. We're going to see the number of cylinders given out in a table. 468, 1174. It's not really telling you much as to what it's providing you or how many cylinders per what car. It's just spitting out the data. Are there more robust ways to strongly align and tell you what car has 4 cylinders? Yes. Are we doing that today? No. Today's just a basic understanding and walkthrough at the very fundamentals of following this cheat sheet. Now doing the formula syntax, we're going to do tally, which is part of the mosaic package, so note that. Tally, cylinders, data equals empty cars. Why do we use the tilde? We're following the method of that general syntax, y by x. We don't have a y variable, but we still have an x variable, more or less. So the tilde cylinders must remain. We'll show you other methods where you do have a y variable and include the x variable. And as we can see again, 468, 11, 7, 14. And with the tidyverse method, empty cars, pipe group by cylinders, pipe summarize n. Go down to the bottom, 4, 11, 6, 7, 8, 14. So we see the cylinders just depicted in 2 columns based on the summarize function. Moving into 2 categorical variables. With the $ method, you do table, empty cars, $cylinder, comma, empty cars, $am. Again, not much information provided, but it does put it into columns between AM and cylinders. Formula syntax, tally, cylinder by AM. So you have your Y and your X. Data equals empty cars. This tells you cylinders, and AM's a little bit wonky. It doesn't completely line up with the start of the column. It starts in the second column. And then lastly, tidyverse, empty cars, pipe, group by, cylinder, comma, AM. So first variable, second variable, and we're going to summarize it. So we have cylinders, we have AM, we have N. Covers all of our bases. Now on to one continuous and one categorical variable. Now this is where you're going to start to see how the $ syntax has its shortcomings. Because if we want to get the mean of cylinders that are equal to 4, 6, and 8, we have to write 3 separate lines of code to depict that. Now, if you're going to be thorough, this might be the way you want to go. If you want to be robust, we'll look at the other methods as well. So if you've been used to doing the $ method, please note that there are other ones that condense these 3 lines into a single, more succinct line of code. So what we can see is mean empty cars MPG with cylinders that are equal to 4. Well, you get the mean of 26, 19 for 6 cylinders, and 15 for 8 cylinders. Now with the formula syntax, mean MPG by cylinders. So it's going to look at your MPG. It's going to get the mean of your MPG based on the cylinders from the data empty cars. And when you look at that, you have the same 3 values, 4, 6, 8, cylinders 26, 19, and 15. And in the tidyverse, it's quite similar to the formula syntax, just using pipes and the group by and summarize function. So empty cars is the data set. Within empty cars, we're grouping by cylinder. And within cylinders, we're going to summarize the data by looking at the mean of miles per gallon. Kind of like Russian nesting dolls with tidyverse using the pipes. This is within this, which is within this. Now, if we scroll down to the bottom, you can see it puts two columns, 4, 6, and 8 cylinders, and it gives you the mean MPG, and it's exactly the same. Quite a robust way compared to the $ function. Now we're going to move on to plotting. Again, we're going to go through one continuous, one categorical, two continuous, two categorical, and so on. So what we can get from our data, hist for histogram, empty cars display, or a box plot. So it's the $ method. You have frequency by empty cars disp, and it creates a histogram. You have box plot. Again, these are very bare bones plots, but we're just expressing how they overlap. So that's the $ function. Now we do not want to reinstall that. Just reiterating with the formula syntax, before we needed to put in the mosaic package, with plots, you need the lattice package. So if you need to, install the package lattice, load it, and then we can run our histogram. Would you look at that? It has a color, but it's a little bit different. It's roughly the same. Now we can do our box and whisker plot, BW plot, display, data equals empty cars. Maybe it's not display, it's disp, whatever that represents in the empty cars package. Here you have your box and whisker plot, and this representing the median, or excuse me, the mean of your data. Lastly, the tidyverse. If you haven't loaded or installed Ggplot 2, please do. If you're used to using the other syntax levels, I strongly recommend you get familiar with Ggplot 2. It is one of the most popular and powerful packages in R. So we're going to do Qplots. We'll describe what Qplots are later, but we got our X variable being MPG, our data being MT cars, and the geom being a histogram. So we're creating a histogram. Here's our histogram, MPGs, and its variable. Similarly, we're going to do a Qplot as a box plot. Our Y variable is going to be disp. Our X variable is going to be 1. Data equals MT cars, geom equals box plot. You must put these in quotes, otherwise it will not read. And there's quite a large, wide box plot, but that's because we're only using 1 as the center, and it's just a singular one. Ain't pretty, but that's just what we're going through today. So we've got 3 different ways we can plot and have the same results with one continuous variable. Okay, now we're going to move on to using one categorical variable. With the $, you have a bar plot that we're going to make. The table is what we're looking at, empty cars, $ cylinder. We're going to do a quick comparison of all 3. I'll show you how to do that so I don't have to keep scrolling up and down. With the formula syntax, instead of bar plot, we're going to do bar graph, tilde cylinder, data equals empty cars. And then the tidyverse, you do a Qplot, X equals cylinder, data equals empty cars. But see, we haven't depicted what style of plot we want. The prior 2 have bar plot and bar graph. If you don't put the geom, it won't know what you want from it. So geom equals bar, so that will create a bar graph. So if I highlight all three, I can run all three, and then we can be more concise. So this is the $ method. This is the formula syntax method, and this is the tidyverse method. They are the same data, 3 different plots. They're a little bit different. They are still all quite ugly, but it's a very bare bones way to create a plot. Moving on to 2 continuous variables. We're going to plot empty cars, disp, and empty cars, MPG. With the $ method, we're going to do an XY plot, MPG by disp, data equals empty cars. And in tidyverse, we're going to do Qplot, X equals disp, Y equals MPG, data equals empty cars, and geom equals points. So these are all going to be scatter plots. And please note the difference between the formula syntax and the tidyverse. We list the X and then the Y. Suppose you could flip it, but that might rotate your graph in tidyverse, so I recommend you do X first, then Y. But in the formula syntax, it's Y by X. So we're going to note that when we look at our plots. So let's look at all 3 of them. MPG disp, exactly. MPG disp, Y by X. This looks roughly the same as this and the same as that. The trend is downward as MPGs decrease, the disp increases. Whereas the disp increases, your MPG decreases. That's the more succinct way of looking at it. So those are scatter plots, looking at 2 continuous variables. Now we're going to look at 2 categorical variables. $ mosaic plot, table, empty cars AM, empty cars cylinder. In the formula, we're going to do a bar graph, AM, data equals empty cars. We're going to group it by cylinder. And in the tidyverse, we do a Qplot, X equals factor, cylinder, data equals empty cars, geom equals a bar graph. Now here's the added element. We want to facet the grid by AM. And let's see what that does to our data. Faceting, here's the tidyverse method. If we did not facet, it would create one single plot. But faceting separates it into 2 subplots, 4, 6, 8, 4, 6, 8. We have 0, 1. They're 2 different categories. So it's created 2 plots. If we didn't do that, it would get messy. You'd have side-by-side bars without color. It'd be difficult to depict. So the facet method is useful, but we're not going to go into that today. As you can see here, you have 0, 1. Trends are the same as the tidyverse method. Kind of looks like Easter colors. And here's a really ugly end from the $ method. Not a whole lot we can tell from it. At least here in the other 2, we have our counts. This is more of a weighted and stacked bar graph. I would not recommend doing the $ method here. So keep that in mind when you have 2 categorical variables. And here's another instance. We're going to do 1 continuous and 1 categorical variable. And this is going to show you the importance of why the $ method works, but is not necessarily as efficient. As you can see, we're going to look again at cylinders 4, 6, 8 in both the histogram and box plot. To save you from bogging down our subtext with a ton of graphs, we have 3 histograms and 3 box plots. Just for the $ method. If we do the formula syntax, we could do it within 2 lines. We're still going to just get 2 plots, but it'll be a lot more succinct. Same with the tidyverse. First one's a histogram, second one's a box plot. Qplot X display, data equals empty cars. Your geom is the histogram. And see, this is where faceting by cylinders comes in handy. So it's going to give us 3 graphs. A cylinder of 4, a cylinder of 6, cylinder of 8. It's going to create a histogram for each. Whereas the Qplot for the box plot, it's going to just lump them together. You can get 3 main box plots. So we're just going to do the formula syntax and the tidyverse syntax today to save you from the headache of me scrolling through 6, 7, 8, 9, 10 plots just for this subtext here. As we can see, for our box plot with the tidyverse method, we have 4, 6, and 8, 3 box plots within one grid. With the histogram, as I mentioned, we faceted by cylinders. You have 1 graph for 4, 1 graph for 6, 1 graph for 8. Why would you facet? Well, you don't want the data in 6 to alter the visualization of your data in 8. So it's good to facet so you can have each subsection weighted on their own data versus being weighted by another one's data and pulling it one way or the other, especially for a histogram. And now we have the factor syntax and 3 histograms for that as well. And this brings us into the next section of data wrangling. You will note that there is not a factor syntax or a formula syntax, excuse me. We're just going to be using $sign method and the tidyverse. So wrangling our data, if we want to subset our data, and this is just a very basic bare bones method of subsetting, it can be a lot more complex than this. $sign method, empty cars MPG of greater than 30. So we're going to show all cars that have an MPG of greater than 30. And in the tidyverse method, this is the way to do it. Empty cars pipe filter your MPG if it's greater than 30. And as we can see below, we get this is the tidyverse method. We get a Fiat, a Honda, a Toyota, and a Lotus. It shows the MPGs and then the remaining portions of the data. And it's exactly the same with the $sign method. So here's an example where you could go either direction and it's still an effective, succinct way of getting your data. Now, what if we want to make a new variable? Which means that we're going to add a column to our data set. So we're using empty cars, but what if we want to look at efficiency? Well, there's no column called efficiency in empty cars. So we created ourselves, empty cars $sign efficient. Well, what are we basing that off of? Empty cars $sign MPG greater than 30 equals true, less than 30 equals false. So this will tell us, it'll give us a column with true and false values to depict whether that car is efficient or not efficient. True being greater than 30, false being less than 30 MPGs. Similarly, the tidyverse method, you are mutating empty cars and creating efficient if else MPG greater than 30, you have true false. Personally, I think the $sign method is a very nice and simple way of creating your new column and subsetting your data. But if tidyverse method is your jam, go for it. So we're going to go through this all together. And it's kind of hard to tell because it's not going to pop up below, but you'll see here we've gone into the empty cars data set and you have a new column of efficient. False, 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 false. Only a couple that are true. Why is that? First column's MPG, 32, 30, and 33. All the rest, or most of the rest, are false because they fall beneath the bounds that we set here in our syntax. Okay. There are even more ways to say the same thing. So even with one syntax, there are often variations that are equally valid. As a case study, let's look at Ggplot2. Ggplot2 is the plotting package that lives within the tidyverse. And if you read down this column, all the code here produces the same graphic. So as we go forward in Ggplot and so on, it's going to produce the same graphic. So it's going to get redundant really quick, but bear with me. This is important to reiterate why. So Qplot stands for quick plot and allows you to make quick plots. Go figure. It doesn't have the full power of Ggplot2, uses slightly different syntax than the rest of Ggplot2. So using Qplot, we're going to do x equals disp, y equals mpg, data equals empty cars, and we're making a point graph. Here's another way to do it. Qplot x disp, y mpg, data equals empty cars. But please note that this line and this line are wrought with errors if you are not careful, because sometimes particular syntaxes work but are considered dangerous to use as they are so easy to get wrong. So for example, passing variable names without assigning them to a named argument, the argument being a point graph. Okay, so we're going to run all three of these and it'll create the same plot 3 times over. We've already seen this scatter plot previously, but that's 3 ways to use Qplot. And here's the ways you could do it in Ggplot. So if you are going to be doing box plots, color plots, Ggplot is there's so much to do there. I have other videos on Ggplot, so I'd recommend you go into my channel and find those. You can customize color palettes, and I'd strongly recommend using this style over the Qplot for your particular purposes. If Qplot can get the job done for you, go for it. It's typically good to use Qplot, potentially if you're doing linear regressions or histograms. But if you're getting a bit more complex and need to assign specific variables or weighted variables or styles of graphs, Ggplot is where it's at. So here we have, again, it's kind of like a nesting doll situation. Ggplot, empty cars. So we're plotting empty cars. How are we plotting it? You do the next subset. So within empty cars, you do geom_point, and the aesthetics are x equals disp, y equals mpg. This is why Ggplot is great. You can be as specific as you want, and it requires a certain degree of specificity in order to get the plot that you want. Here's another way of doing it. Ggplot, your data equals empty cars. We're doing geom_point, which is a point plot, scatter plot. We're going to map it by the aesthetic of x disp, y equals mpg. Third way here, Ggplot, empty cars, and the aesthetic is x disp, y mpg, and geom_point is the plot. So you can shift your x, y up above and make it a point graph. And doing so, sometimes you can have other schematics. So you could put within here colors. You could say color, brewer, and then choose one of those palettes within there, and it'll make the points based on a certain color set. But you might need to choose which variables receive what certain colors. We're not going to get into that today. And then lastly here, Ggplot, empty cars, the aesthetic, x equals display, geom_point, the aesthetic, y equals mpg. So there's multiple ways to get the same job done, as we can see right now. This looks the same as this, and as this. So that's 4 different ways to get the same result. Which I guess will reiterate, if you can be succinct with your code, don't worry about it being as efficient as possible. I mean, succinct code is efficient, but if you feel or see someone else doing it slightly differently, don't worry too much. There are multiple ways to go about it. All right, we're almost done. Moving into GG formula, which is the third and a half way to use the formula syntax. But you get a Ggplot 2 style of graphic. GF point, MPG by disp, data equals empty cars. Would you look at that? It looks very similar to our Ggplot, if not exactly the same. And lastly, formulas and base plots. Base R plots will also take the formula syntax, although it's not commonly used. Plot, MPG by disp, data equals empty cars. And that's a very rough way of going around it. It's the same scatter plot as before. So, to conclude, the $ syntax, sometimes called base R syntax, is one of three prevalent R syntaxes. The other one is the formula syntax, and you have the tidyverse syntax. Educators often try to teach within one unified syntax, but most R programmers use some combination of all the syntaxes. I do, and most anyone does, because there's a lot of overlap and play within your data and within R. I just wanted to use today's video to express that, to show that, so then maybe you can see which might work best for you, what you prefer, or some shortcuts you can take to remove redundancies in your script and make it a lot more concise. If you have questions, leave a comment below. I'm going to attach the syntax cheat sheet as well in the description, and that way you can go through it yourself and have it at your fingertips as you go through your own data. All right, thank you.